So, we are continuing. We're still in section 2, believe it or not. It's a fairly lengthy section. Also, real quick, just to give you guys a heads up, we're probably going to take that quiz on filling out that circle with all the radian angle measures. We're going to take that quiz tomorrow, so make sure that you guys are ready for that. I think you guys all did pretty good with it, so.
Are you gonna have that up there?
I'll have that just like that. So every angle that's covered will be covered. You guys can see pi over 6, pi over 4, pi over 3, and pi over 2. Because everything else is multiples of that. You don't have to write in the degrees.
If we do we get extra credit?
Nope.
Dang.
All right. So what we're talking about today is going to be arc length. Okay.
Do we have to draw crescent circles too?
Yes, you have to.
Oh, boom roasted.
All right, so to start out with, I just want to clarify when we're talking about arc length, I want to make sure everybody knows what we're talking about. So arc length is the length around the circumference of a circle, not the entire circumference, but just like a piece, right? So what I'm going to have us draw.
Arc length is 2 times the angle measure, isn't it? Or is
No,
it equal?
just wait. So an arc is going to be like what I'm drawing in blue here. And we're going to use an S to represent arc length. And of course an R for radius. And then we have theta there, which is our angle. Okay. So I'm going to start with our formula, sort of how we defined radians at the beginning of the section. Okay. So what we started with was theta in radians equals S over R. Okay. We did that at the beginning of section 2. Because this theta is really just a ratio of S to R, right? If I think this is where you're going with maybe, if S is twice the length of the radius, then theta is just 2, right? If S is 25 and my radius is 10, then theta is just 2.5. We went from there. Theta was just that ratio, okay? So what we're going to do is basically I'm just going to rearrange this for arc length. So if I want to get S by itself, we just have to multiply both sides by R. So arc length equals R theta.
Is that all we're doing?
That is our formula for arc length, but I want to clarify a couple things because we've got to understand how to use formulas. Don't just try to plug whatever numbers we've got into them. Okay? One thing I mentioned earlier in section 2, notice that our radius here and arc length are both going to be measurements of distance, right? So they have, in order for this to be true, where this is just a ratio, they have to be in the same units. Okay? So if our radius is measured in inches, S has to be in inches. If our radius is in millimeters, then S has to be in millimeters. Okay? The other thing, and this is honestly, this is what I see people miss the most in this whole section. Theta, in order for this to work, this was defined as radians. So here, theta has to be in radians. Okay? That formula does not work with degrees. It will not work. You have to convert. So in order for this to hold true, theta, the angle that we plug in there, has to be in radians. Okay? So you've got to pay, don't just take whatever information you're given and just try to shove it into the formula. You have to make sure that the units are correct and that the angle is in radians. Okay?
How much you pay me?
Hmm. All right, why don't you wait and see if we answer it in examples here. Okay, so the directions are going to be to find the arc length given other stuff. So the directions on the homework will say find the arc length given the radius of a circle and the intercepted angle or something like that. Basically, it's going to give you the radius, the angle, find the arc length. So number one, we've got an angle of pi over 3 radians and a radius of 4 inches. So when I'm dealing with formulas like this, I always like to start with the formula or the equation that we're working with so that I can see exactly where I'm plugging things in. So I'm just going to start with S equals R theta. And then I just plug stuff in where it needs to go accordingly. So I've got my angle, my radius is 4. So I'm plugging in 4 for my radius, pi over 3 for theta. And then I know to multiply fractions. You just multiply straight across. So that's 4 pi over 3. Now again, this is one of those cases where I know I like to harp on keeping exact values whenever possible. But if I want an arc length in inches, does 4 pi over 3 inches tell me a whole lot?
No.
No. Go ahead and type that in and let's round to like the nearest tenth. It's 4.1 or 4.2? 4.2?
Well, I've got to find pi. There it is.
There we go.
That's all we're doing.
No.
What did you guys?
Okay, so number 2 is going to be the exact same type of problem, but we're going to be given an angle in degrees.
Understood.
125 degrees and 7 centimeters.
125 over 1 times pi over 1.
Yeah, the first thing I have to do is convert this to radians, which do you guys remember how to do that?
125 over 1 times pi over 180.
Multiply by pi over 180, which is just 125 pi over 180. And then I would reduce that just so I have smaller numbers to work with. I know those are both divisible by 5. And then 180 divided by 5, I believe, is 36. So that would be my angle, or theta, in radians. So that is what I need for my formula. So that's just going to be r theta 7 times 25 pi over 36. And you can just type that in.
I have a question. Can you just do that straight in the calculator? 7 parentheses 25 pi over 36.
Yep. Mm-hmm.
Or would you rather have us do it in the multiplication way?
You can do it, yeah, you can just do it 7 parentheses 25 pi divided by 36.
Round to nearest 10.
Yep. So what do we get? 15.3? And what would our unit be on that?
Centimeters.
Yeah, because our radius was in centimeters. That also has to be in centimeters.
You gonna count us wrong if we forget to label?
Probably not if you forget to label, but in stuff that we're going to be doing, the units that we're using are going to be really, really important. So forgetting about them can cause problems. But all right, and then we get out at 2:11, right?
Yes.
That's it for today.